Hello guys, this is the sixth video of the capacitance and the third video of equivalent circuit. Now, in this video, we should deal with this type of circuits. Here, these are the two parallel plates. In between the parallel plates, different media having different thickness, different dielectric constants are there. You assume thickness of distance between the plates, that means thickness of the medium gap between the two plates is either E or E something. Area of each plate you take smaller because we are taking this plate is A, that plate is B. Therefore, our aim is to calculate equivalent capacitance across A and B. Okay? You take area is a small a, or you can take area is also, that is capital A, big A. Okay? Now imagine, for your convenience, all the parallel plates are identical parallel plates. Okay? Now in this case, how can you calculate the equivalent capacitance? Now first we will start this diagram. I am giving, this is equation 1. Now, for equation 1, if you assume this plate is positive and this is negative, that means A and B are connected to positive and negative terminals of this cell, then A plus B minus, therefore this side is, this is plus, because this is a single plate. This is minus, this is minus. This is also a single plate. Okay? Now, if this is the case, you can convert this diagram into an equivalent circuit. That is, first part is capacitance C1 and the second part is capacitance C2. So this part is your B and this part is your A. Okay. Now the B is minus, means minus minus, they are connected together. Plus plus, they are connected together. That means this shows that the two capacitors are parallel. If the two capacitances are parallel, then what is the equivalent capacitance? That is C1 plus C2. Now what is C1? C1 is this half, that is general principle K epsilon 0 A divided by D, or here thickness is T. But in this case, K is K1 and area is a half plate. Mark, half of area is covered with a dielectric constant K1 plus another term C2. C2 is similarly K2 epsilon 0 A by 2 divided by D. So here area is half of, and K1 and K2 are dielectrics. Then so Cp, you can find out common term epsilon 0 A divided by 2T perhaps. This is K1 plus K2. So this is your value. Okay? This is the value. Now let us come to the second circuit. I am giving this circuit is a second. Let us come to the second circuit. Now in the second circuit, same principle, A is plus B is minus. Therefore this is divided like this. So inner side is, this is plus, this is minus, this is plus, this is minus. This is the partition of dielectrics. So plus side minus induces, minus side plus induces. Okay? And this type of a combination is, the equivalent circuit is, this is A, so this is plus, then minus, then plus, then minus. Plus, then minus. Okay? Plus minus, and this is B. This is your circuit, A and B. Okay? So now this circuit shows that they are in series grouping. Therefore the equivalent circuit is CS. This is C1 C2 divided by C1 plus C2. C1 C2 divided by C1 plus C2. So this is the formula. Okay? Now if this is C1 C2, so what is C1? C1 is the same principle. K means first media K1 epsilon 0. A means total area is covered in the second case, divided by distance. In this case distance is total t, but here distance is half, d by 2 into same formula k2 epsilon 0 a divided by d by 2 whole by, this is whole by sum of these two, that means you take epsilon 0 a 2 epsilon 0 a by 2, you take out common, this is k1 plus k2, sum of these two, t by 2 means 2 come to the numerator side, take out 2 epsilon 0 a by t common. Now 1 epsilon 0 a by t cancels, okay, 1 epsilon 0 a by t cancels, then perhaps 1 2 cancels. The answer is, this is 2 k1, that is epsilon 0 a by t into 2 k1 k2 divided by k1 plus k2. So this is the value. See this, perhaps there is a 2, okay, 2 epsilon 0 a, yes, there is a 2, 1 2 cancels, 1 2 cancels, 1 2 remains here, okay, or you take 2 is somewhere here, 2 epsilon 0 a by t into k1 k2 divided by k1 plus k2, okay. Now if you, that is, when a condition is given, two parallel plates are suppose filled with two dielectrics equal halves. First, this condition, vertical direction, it is split, then it splits along the transverse direction. One is a longitudinal direction, another one is a transverse direction, equal half. Then one represents for CP, another represents for CS. Okay. Now these are the equivalent circuits. If you draw the equivalent circuit, I think it will be easy for you to solve it. Okay. Now from that you can find out, that is, what is CP into CS? What is the value of CP into CS? If same two dielectrics are divided like this, a problem comes. What is CP into CS? CP is given, into CS is given. You take the product of these two. Okay. If you take product of these two, I think k1 plus k2 first cancels, 2 cancels. Okay. If you take product of these two cancels. Here k1 k2 in the numerator it remains k1 k2. Then epsilon 0 a by t, epsilon 0 a by t twice, that means epsilon 0 a by t power square. So this is the value of Cp into Cs. Okay. This is the value of Cp into Cs. Similarly, if you want to take, that is Cs by Cp, what is this value? Cs by Cp. You take this in numerator and this part in the denominator. Okay. Cs divided by Cp. Then that part in the denominator. Then in that case, you can find out the value, that is 4 k1 k2 divided by k1 plus k2. This is the value. 4 k1 k2 divided by k1 plus k2. k1 plus k2, k1 plus k2. This is a whole square. So this is your formula. Cs by Cp is 4 k1 k2. This 2 divided means 2 comes to opposite side, 2 cancels, 4 epsilon 0 a by t cancels, k1 plus k2 square, that is in denominator, k1 k2 is in the numerator. These are the values. Okay. So therefore with this much combination you can find out this. Another thing is, you think this is a theory, every book this is written, every entrance guide. If you imagine why the dielectric is exactly divided into equal two halves, why not in different conditions? Suppose if you take this example I am taking, that is this example, this is should say T1 and this is T2 and T1 plus T2 equal to let T. So now in this case you can write what is CS. CS is, this is k1 epsilon 0 a by 2, first term is that is T1 by 2, and the second is K2 product K2 epsilon 0 A by T2 by 2 whole divided by 2 epsilon 0 A by that is 2 epsilon 0 sorry this is divided by C1 plus C2, that means epsilon 0 A you take out common, C1 is K1 by T1 by 2 plus K2 by T2 by 2. The formula is like this. That means if it is not divided into equal to halves, you can take one section thickness is T1, another section thickness is T2. So maybe T1 is T by 3 and T2 is 2 by 3. That is first one is 1/3 part, second one is 2/3 part. If data are given, you put this equation, put these values. Therefore, your mind, that is, you think if this is given, first you take equivalent circuit, then find out C1, C2, then substitute whether they are equally divided or unequally divided. Okay. Similarly, if area is divided into here two exact halves, I am writing A by 2, A by 2. Suppose this area is 1/3 area, this is 2/3 area. So here you can correct. This is A by 3, this is 2A by 3. That's all. That is you take CP, that means epsilon 0 K1 epsilon 0 A by 3 by T plus K2 epsilon 0 2A by 3 divided by T. Okay, then common is epsilon 0 A by T, you take out common. This is K1 by 3 plus 2K2 divided by 3. Now if the values are given, you can put it and calculate it. Okay. Now let us consider, that is third figure number 3. Here the medium is divided parallel to plate longitudinally into two halves, and further up is divided transversely into two again equal halves. We are taking equal. Okay, first you solve for equal. Now if this is positive, this is plus, this side is minus, okay, then this is plus. Therefore these two groupings is series. This is a series. Okay, but this plus and this is minus. These two groups they are in parallel. That is medium K2 K3. These two capacitors where the medium K2 K3 is present, they are in parallel, and K2 K3 along with K1 they are in series. Okay, so now you take the equivalent diagram for that point 3. Equivalent diagram is, that is, first to C, this is, then this is C1, then C2, then this is C3. Okay, so this part is B, this side is B, that side is A. So this is your equivalent circuit. Okay, now if once you are able to write the equivalent circuit, then find out the values. So what is C1? Mark, that is C1 and C2. They are in parallel, and finally these two combinations are series. This is parallel and this is series. Okay. So equivalent circuit is, that is A, this is C1, this is C2 plus C3, then this is B. Then find out CA. Now what is C1 here? C1 is K1. C1 is K1 epsilon 0 A divided by D by 2. What is C2? C2 is K2 epsilon 0. A is half and thickness is half. A is half, thickness is half, and C3 is exactly K3 epsilon 0, A is half and D is half. A is half, D is half. So these are the values of C1, C2 and C3, and you take substitute here and you can solve it. Okay. Similarly, if again you can imagine this thickness, they are not exactly divided. If they are not exactly divided, then you can put C1H K1 epsilon 0 A. First thickness is let D1. In this case, D1 is D by 2. Then second C2 is K2 epsilon 0 A by 2 divided by D2. Okay. Then C3 that equal to K3 epsilon 0 A by 2 divided by, you can take that is D2. That is both are same, D2. So what is D1 and D2? So D must be equal to D1 plus D2. That is distance within the parallel plates must be equal to D1 plus D2. If D1 is 1/3, 2/3, 1/4, 2/4, 3/4, accordingly you can put D2. So these are the sums related to this equation. Okay, this diagram. Now here this portion is divided into two parts. This remains the same. They are divided into two, one transverse and one longitudinal. Here longitudinal, then transverse. Okay. Now you come to the fourth figure. Okay. Now in the fourth figure, it is divided equally along transverse direction K1, but second half of the transverse is further divided into longitudinal direction. Okay. That means this is if plus, this part is if plus, this is minus, then this is plus. Therefore, this is first capacitor K1, then this is plus means this is minus, this is plus, this is minus. So therefore, these two capacitors K2 and K3, that is they are in series. I think these two are parallel. So this is C2 and C3, these two are parallel, and this is connected to, that is C1. So C1 side, you take one side A, another side B. So this is the combination. Okay. Now C2, C3, these two are series. This is plus minus, this is minus, this is plus. Okay. Now this is plus, this is plus. Now what is C1 here? You put C1 equal to K epsilon 0 A. A means A by 2, K is K1, thickness is D or T. Then what is C2? C2 is again K epsilon 0 A. K means K2 epsilon 0 A. A means A by 2, but thickness is T by 2. Now what is C3? That is K epsilon 0 A divided by T. K is K3, A is A by 2, and thickness is T by 2. Okay. Now substitute the values here. You take first, these two are in series. This is first, then these two, and also second, these two are parallel. So find out the value of CA. Okay. Now by similar method, if you imagine either one section is divided into three pieces, K1, K2, K3, K4. Similarly, here K2, K3, K4, K5, K6 like that. You can write first derive or first write the equivalent circuit diagram. It is better. Then find out the capacitance of each and every capacitance and put this formula. Then you will get the answer. Okay. If you like this video, like it, share it and subscribe it. Thank you all.